Hello dear friends. I am here with the new Arduino training video. This is the third video of the series. If you have not watched it, I recommend you to watch the previous videos so that you do not miss valuable information. In the previous videos, we made a general introduction to Arduino, downloaded and installed the Arduino IDE on our device and made a general review of the IDE. In this video, we will try to understand the Arduino logic with you. Have a good time. In the last video we took a look at the file, edit, sketch tools and help menus of the interface. Now let's take a brief look at the other tools. Just below the file menu is the compile option, which allows you to compile your code and check for errors before uploading it to the Arduino. The arrow next to it allows you to load the code. In fact, if there is an error in the code you have written, you cannot load it anyway. The Arduino will not allow it and will show the error. This is a great feature. Now let's check without typing anything and try to install it. See, Arduino checks and says no problem. The codes are already checked when we try to install it in the same way. Moving on, below again is the file shortcut where you can find the files you saved earlier. If you have uploaded a file to Arduino's cloud repository where the cloud icon is located, you can see it here. The second one is the dashboard manager. I don't want to go into too much detail here and confuse you. You can think of these places as stores where you can get some downloads when you need them. There is another shortcut to download libraries just below. We will talk more about libraries when the time comes. Let's not waste time with the rest, we won't use it much anyway. Now let's start practicing. Now friends, if we energize Arduino, we said that 3 and 5 volts of energy always comes out of the power pins. Let's try this with a multimeter. Of course, it is not necessary to measure with a multimeter. I just want you to understand the logic of the work. The leads of my multimeter are a bit thick, so I can't touch the pins directly, so I will use these jumper cables. First I connected the red wire to the 3.3 volt output pin. The black wire will remain fixed on the GND pin. Let's see if there's 3.3 volts here. I set the multimeter to 20 volts DC and touched the probes to the same colored wires. Yeah, we're seeing 3.32 volts. I would like to remind you that we did not install any code on Arduino. Now let's check the 5 volt pin. I just plugged the red wire into the pin that says 5 volts. There are 5 volts here, which means that we can feed some sensors, modules, motors, etc. that we will use with Arduino directly from these pins. However, you should know that Arduino is only designed to work with currents around 0.200 milliamperes. This means that we can't feed components that operate at higher currents directly to the Arduino. We need an additional power supply. Now let's find out how we can get controlled energy, so PWM signal, from Arduino. So I keep my GND connection in place. I also plug my red wire into any of the digital pins 2 to 13, for example digital pin 2. First, let's go back to the code page and tell the Arduino what we want to do. Here we see the ready-made headers. All code should be written in these two headers. So inside the curly brackets of void setup and void loop. What is written after the two slashes inside the brackets are just comments. Arduino does not read them. You can write whatever you want after the two slashes. Look, now I want to compile the code without writing anything. Arduino found no problem. Now I delete one of the two slashes and recompile. See, the color of the text has changed, which means that Arduino will now read this line as code. The same thing happens when we delete one or two of the good lines. Let's check again. Yes, Arduino says there is no such code in the software. I hope we understand the logic. I am now deleting these comment lines. We have nothing to do with them. Friends, Arduino reads the void setup header only once, so we do not write code that will run continuously in void setup. Here we write the code that tells Arduino which tools and which pins we are using. Arduino reads the void setup once and immediately enters the void loop. It then repeats the code inside the void loop continuously unless you write the stop code to the Arduino or de-energize it. Now I need to tell the Arduino that I want to use digital pin number 2. And I write that I want to get the output voltage from pin number 2. When writing the code, make sure you pay attention to the order of letters and semicolons. If even one letter is wrong, the code will not work. The application already helps a lot with this. As we write the code, Arduino automatically shows the correct form of the code we want to write and other options. For example, if I lowercase m here or omit e in the suffix, the code will not work. Inside the parenthesis I write that pin number 2 is the output pin and I don't forget the semicolon after the parenthesis. I load the code and see if I get power from pin number 2. There is no energy here, because we have defined the pin, but we have not told the Arduino what to do. Now let's write this. Digital pins operate with 1 and 0 or high and low logic. So we tell the Arduino to make pin 2 high or 1. Here we use the digital write command. This time I will try without the semicolon. I want you to see how the system works. Yes, we made a mistake again, but mistakes happen all the time and they help us to understand better. Yes, now we have 5 volts of power. Now let's use this energy to light an LED. If you don't have basic electronics knowledge, I suggest you do some research on this topic. Because if we are going to deal with Arduino, we should at least learn the basics of software and electronics. Here I will use one blue LED and 10K resistor. I do not go into the topics of LEDs and resistors, ohm law resistance calculation. There are already many videos on YouTube on these topics. But still, if you, my followers, want, I can prepare videos like basic electronics lessons, of course. Here I will use breadboard so that we understand the logic. Think of the horizontal, red and green lines at the top and bottom of the breadboard as 2 separate straight wires. We usually connect a positive to red and a negative to green. The vertical holes in the center are divided into groups of 5. Each 5 holes is a line. The middle part is insulated and separates the upper and lower parts. Now I connect the 5-volt and GND connection from Arduino to the line with red and green lines on the breadboard with 2 jumper cables, red and black. The colors help us not to confuse the plus and minus lines. Almost all circuits have a red plus line. Now we have 5 volts and a minus line on the breadboard. From here we can build more circuit elements. For now we will use only one LED. When connecting the LED to the circuit we must pay attention to the positive and negative legs. If the legs are uncut, the longer leg is always the positive line. If the legs are the same length, the smaller part inside indicates the plus line. I connect the minus leg of the LED to the minus line from the Arduino to the breadboard. The plus leg enters one of the 5 holes below. We also transfer the energy through the resistor to the LED so that the LED is not damaged. We take the plus line from digital pin number 2 and connect it to the resistor. Yes, the LED is on because there is energy on pin number 2. Now let's stop it with a command. We write low here to de-energize pin number 2. If we write 0, it will do the same thing. Yes, LED is off. Now I want the LED to turn on and off automatically. Let's try just by writing digital write high and digital write low. When we turn it on, we see that the LED stays on, because we didn't give the Arduino a waiting time and the blinking happens so fast that we can't even see it. I write a delay between the codes and set 1000 milliliters seconds as the duration. The delay is calculated in ml seconds, which corresponds to 1 second. Let's load the code. It stays on again, because the Arduino rotates so fast from line 7 to line 9 and back to line 7 that the LED doesn't have time to turn off. So we need to write the following delay code. Now he has to work. Yes, it turns on and off in 1 second intervals as we want. Believe me, it's always a pleasure to see any code working, whether easy or hard. Let's try to reduce the time interval. That's it for this video. I hope it gave you something. If you want to support, just subscribe and like it. Please feel free to write your questions and suggestions in the comments. Don't forget to turn on notifications to be informed about the continuation of the videos. Take care.